Hello, and welcome to the Chocolate Academy Online. Today, we're going to be discussing a fundamental technique, that of tempering chocolate. Chocolate in its pure form, intended to be used to create bonbons, candies, or a variety of other applications, must be tempered prior to use. Tempering chocolate is all about forming stable fat crystals inside of our chocolate, and this is why it's often referred to as pre-crystallization. Pre-crystallization sets up our chocolate so that as it turns from a liquid into a solid, it does so in a uniform way. This process provides the best possible appearance and texture of our products, ensuring that they undergo little change over time. From an artisan perspective, tempering is required in order to promote our melted chocolate to set quickly and uniformly, while also providing a brilliant gloss and a superior hardness. In addition to those qualities, we also want the tempered chocolate to provide a good quality snap and sufficient retraction, allowing our candies to be removed from the molds. Well-tempered chocolate is also more resistant to heat, meaning that it can be held in the hands for a long period of time without melting. Tempering chocolate also helps to prevent the unsightly occurrence of fat crystals on the surface of our chocolate during storage. This is also referred to as fat bloom. Here in my left hand, I have an example of chocolate that was put into a mold without being tempered. And in my right hand, I have an example of chocolate that was tempered before being put into the mold. The difference between the two bars is quite clear. In my left hand, we have a bar that shows a variety of different characteristics, such as fat bloom, uneven retraction from the mold, and very streaky and grainy texture on top, whereas the bar made from tempered chocolate is quite uniform and has an attractive gloss. We can also see in my left hand that this bar has already begun melting in my hand, whereas the bar from my left hand has not begun to melt at all. Chocolate which has not been tempered properly, or which has not been tempered at all, will not exhibit the desired characteristics. Here in front of me, I have several examples of chocolate that has not been properly tempered. Here we have a chocolate that has a dull gray appearance. Here we can see a chocolate that exhibits a very rough, irregular texture with lots of fat bloom on the surface of the chocolate. We have a tablet that's been removed from the mold, and we can see that it has very little shine and it has a very irregular look to the surface. We have streaks, as well as we have very dull places and some shiny places, all resulting from improperly tempered chocolate. We can also see here that we have some chocolate that was put into the mold which was not tempered at all. This chocolate has no retraction whatsoever, so as I flex the mold, we have the inability to remove the chocolate from the mold. We can also clearly see on the surface a very irregular pattern of fat crystals on the surface of these bars. Chocolate which has not been properly tempered also will not have the desired snap. This chocolate bar is very easy to break, it's very soft, has an almost rubber texture to it. So, why is all of this happening? Chocolate consists of a high percentage of cocoa butter. Here we can see the basic composition of Callebaut 811 dark chocolate. The main components are sugar, cocoa solids, and cocoa butter. It's this cocoa butter that's the reason behind the need for tempering. Cocoa butter is a fat with very unique properties. When the cocoa butter is melted and then allowed to re-solidify, it has the ability to form 6 different solid crystal shapes. If you simply melt the cocoa butter and then allow it to re-solidify, it will re-solidify into all of the different crystal shapes in an irregular network of crystals. Only one of these crystal shapes is considered stable. This stable crystal is sometimes referred to as the beta crystal or the form 5 crystal. Only this stable crystal shape will impart the desired characteristics of tempered chocolate that we're looking for. So, whenever we temper chocolate, whether it's dark, milk, white, or ruby chocolate, we're actually tempering the cocoa butter that's inside of the chocolate, and the other ingredients involved essentially have nothing to do with the tempering process. While the physics of this process are quite complex, the actual act of tempering chocolate is quite simple once well practiced. So, how do we get those good beta crystals to form inside of our cocoa butter? This process may be achieved through a variety of methods. However, regardless of the method, the same essential criteria must be applied. These essential criteria are time, temperature, and movement. Temperature is the most easily measured. However, equal attention must be paid to both movement and time.